Earth passes through the ashes of an exploded star.
Scientists have discovered striking evidence that Earth is traveling through a cloud of radioactive dust left over from a star explosion millions of years ago.
By analyzing samples of ancient ice from Antarctica, aged between 40,000 and 80,000 years, researchers found traces of iron-60, a rare radioactive isotope that only forms inside very large stars and is released into space during supernovas. This material is not naturally produced on Earth and serves as a kind of cosmic fingerprint. The study, led by an international team from the Helmholtz-Zentrum Dresden-Rossendorf, HZDR, in Germany and published in the journal Physical Review Letters, shows that the solar system is traversing a region called the Local Interstellar Cloud. This cloud of gas and dust contains remnants of ancient supernovas and has enveloped our solar system for tens of thousands of years. According to calculations, we are near the edge of this cloud and should exit it in a few thousand years. Iron-60 arrives on Earth along with interstellar dust that enters the atmosphere and ends up trapped in the polar ice layers. Previous research had already found this isotope in marine sediments and even in recent snow, but clear proof that the current source was indeed this interstellar cloud was lacking. Now, with the new samples, scientists were able to confirm the origin. The amounts of iron-60 were lower in the older ice, indicating that we entered a denser or richer part of this material relatively recently. This also helps to rule out the idea that the traces are merely faded remnants of much older explosions. To carry out the research, scientists transported about 300 kilograms of ice from Antarctica to the laboratory in Dresden. After a long process of melting and filtering, only a few hundred milligrams of dust remained. They very carefully isolated iron-60 and used other known radioactive isotopes, such as beryllium-10 and aluminum-26, to verify that they had not lost any material during preparation.
The final detection was made in Australia, at the Australian National University's Particle Accelerator, the only equipment in the world capable of identifying such small quantities. Imagine searching for a needle in 50,000 football stadiums filled with hay. The device can find these few iron-60 atoms in just 1 hour. It is an extremely sensitive technique, developed over years of international collaboration. This discovery is important because it allows us to better understand the history of the Sun's galactic neighborhood. The local interstellar cloud is part of a larger bubble in space, probably created by several supernova explosions in the past. For the first time, we have the chance to study the origin of these interstellar clouds by analyzing the material they leave on Earth. The team is already planning new studies with even older ice samples, from before we entered this cloud, thanks to projects like Beyond Epica, which seeks to recover ice hundreds of thousands of years old. In short, our planet does not live isolated in space. We are constantly collecting cosmic dust that tells the story of stars that exploded long before we existed. These are minuscule quantities, which do not represent any risk to life on Earth, but reveal a dynamic and connected universe, of which we are a part. This interstellar fingerprint preserved in Antarctic ice helps us reconstruct the path that the solar system has been following for tens of thousands of years. DOI 10. 1103/NXJQJWGP